And good morning, super friends. Hope you're having a great day so far. I acknowledge the traditional owners of this land, the Whadjuk Noongar peoples. I pay my respects to their elders, past and present, and to Aboriginal elders and peoples from other communities who may be taking part in this live stream today. You are most welcome. Where are we? Okay, back to the chat. Into the chat. Where are we? Okay, so good morning to many people. How many have we got here so far? 30. So Michael, Austin, Chip, Woodshop. Yes, I know wood for sheep. It's boring. Very boring. Some call it fun. Russell, Dodgy. Did I say hello to Dodgy? No, I didn't. Good morning, Dodgy. Gerald, Family Plans, Don S is here, Stephen, James, Sion, and then James again. Cable tie. What are you doing here? You should be riding up Mount Dandenong. Jump on your bike. Go for it. Imogen's here. RP, Mike. Any mules? Yes. Austin landed and processed at Melbourne Airport. Should be there within the week. Nice. So what Austin is talking about is the circuit he's been working on for automatic source selection for power over Ethernet. He's very kindly assembled a board and sent it to me. Tracking says that it's in Melbourne right now. Kim, good morning. Henrik, welcome Henrik and the Celtic Beast. Oh, cable tie, doing some woodworking. What sort of woodworking? Up until just minutes ago, I was helping Lachlan with putting up some Dexian pallet racking in the back. So I'm using Dexian pallet racking for the front part, like the structure to build my clean room, and that is all part of a bigger plan for the whole factory, not just my area. He's using Dexian racking to build a mezzanine in the back part where that he uses. So he wants an area on the ground floor, which is going to be a big open space for doing things like working on heavy machinery, which they roll in, they bring it in forklift and in through the loading dock and then into the back of the factory. And he wants an area that he can bring in machines and work on them. And then above that, he's going to have like an electronics workroom. They currently do that work in the other factory next door, and he wants to move that into a cleaner space on the mezzanine above the area where they're going to be working on equipment. So that was actually kind of what got me down the track of finally making the decision about what sort of structure I'm going to use to build the cleanish room, because I had a few different options. I was going down a couple of different paths. I really thought that I was going to end up just building a pine frame, regular construction sort of thing, just like building a house. And then it was because Lachlan was setting up for the pallet racking out the back and building the mezzanine, and I was sitting there going, this is all quite inspiring. I like the way this is going, and his ideas about how to use pallet racking as structure. And then you can line it or do whatever you want and end up with a structure that is it's quite mechanically rigid, but it's very flexible. It's like supersized Meccano, so you clip it together in the configuration that you want, and if you want to take it with you later, you can unclip it, take all the pieces away. So tickets going to be available. Sorry, I skipped the chat. I'm just going to catch up to that one, doing some woodworking. David, say good morning. Yeah, Sion's comment. Damn, Austin's Creations, I thought you were coming to Melbourne. Right, when I first saw that comment, landed and processed at Melbourne Airport, Austin, I thought that you were arriving in Melbourne just for a second, and then I remembered, no, you're sending me a package. That's what the tracking is all about. Oh, okay. The woodworking that Cable Tie is doing is making shallow drawers for his electronics workbench. Cool. Should share some photos of your workbench. I want to see it. Yeah, so my friend Sam has just built a workbench in his garage area, but this is kind of more for mechanical stuff, but a little bit of electronic as well. And he just posted some photos on Facebook a couple of days ago, which is kind of inspiring. He's doing a good job. Yeah, Austin says he wishes. Yes, Austin, one day we've got to meet up in person. You've either got to come to Melbourne or I'm going to come and see you. One way or the other. Okay, so getting down to the question from David. So it was, John, what's the inside info on Everything Open? Are tickets going to be available? Tickets are available right now, I believe. Everything Open 2023. I'm going to pull this up. So let's have a look at this. So Everything Open is like a, I don't know the term to use. It's not a successor to LinuxConf AU. It's not a replacement for LinuxConf AU. It's kind of a placeholder before the next proper LCA happens. But to call it a placeholder is feels a little bit insulting because it's not really a placeholder. It's a proper conference in its own right. It's just that it is not it's not being done through the usual LinuxConf process. It's being organised by a group of people who decided that they couldn't stand the idea of a conference not happening, and so they just jumped up to organise it themselves. And which is kind of the spirit of LCA. And so ticket sales open. So if anybody's interested, I'm going to chuck this. Ooh, they've got a .au domain now. Yeah, I have a .au domain as well. I now have oxer.au, which I'm not actually using for anything. I haven't done DNS setup or anything. At least I don't think I have. Maybe I did. I don't know. Anyway, I'm going to start. At the moment, I've got the domain oxer.com.au, which I've been using for quite a few years. Now, I wonder if I'm in that photo. There's this background photo from some previous conference. It's the that one with the swooshy logo on it. That was Ballarat, I think. That was LCA Under the Stars. So where was I in the crowd in LCA Under the Stars? I don't know. I might be in there somewhere. Someone's falling asleep just there. Oh yeah, there are plenty of faces I recognise in this this little group here and here. Oh, it looks like Alistair just there. Yep. Yeah, there's lots of faces. There's Mike, Simon. Anyway. If you want to go to Everything Open, where are we? View history, view actual size. Yeah, if you want to go to Everything Open, link is there. Michael says, I can see Brett, face always in the camera. Don, g'day, greetings from Kona, Hawaii. Hang on a second. The usual throat problem. Sneak an AirTag into his lunch? What was that about, Scott? Oh, Mike said, sorry, I don't know what construction techniques you're talking about. Right, so this is back to the talk about the Super Lab, and what I'm using is what I'm going for is Dexion palette. You can see in my search history there, palette racking 3D model. So what I've ended up going for is I'm using this style of palette racking, which is designed for pallets, obviously. You sit stuff on it. The beams come in different lengths. The uprights come in different lengths, so you just get the sizes that you want, and you clip them all together, and you can do all sorts of constructions, and it's like super size Meccano. So by clipping it together, you can make all sorts of interesting things, like there's a lot of these examples that you see are just for storage of pallets. It's warehouse storage. But if we look at Dexian pallet racking mezzanine, for example, we'll probably get better views of the sorts of things you can do. So there you can see someone has used, that doesn't look like, oh, it's Dexian mezzanine floors, but that's not regular Dexian pallet racking, that's something different. But here's an example. Someone has used Dexian pallet racking to build a mezzanine area, and then they've got a working area below it. And pallet racking supported mezzanine, that is, I don't think that's Dexian, it might be. Could be. Anyway, that's the idea. So what you can do is use Dexian pallet racking basically as supersized Meccano, and then build big structures that can be very strong, and then you put flooring across the top and you can build yourself whatever you want. And if you need to reconfigure it, you unclip the beams and move them around and put them together in a different way. Stephen W says, decided on your ceiling height. Well, kind of. It's going to be, it's kind of dictated by the spacing on the pallet racking, because it's got the holes in the uprights to clip it into, and the exact final height is going to be set based on how that all fits together. So for those of you who didn't see this on Discord or where am I? Camera. I'm just looking for pictures here so I can show you. I could also take you for a little walk out the back. Here we go. So this was a couple of days ago. What day was it? Doesn't matter. 23rd. 3 days ago. So yeah, Friday. This is orange crossbeams arriving. So these were coming in on, they came in on a truck on Friday, and we used the forklift to lift them off. So these are 4.2 meter crossbeams, which are going to form the ceiling of the clean room. So there are going to be uprights running down both sides of the clean room. So one against the wall of the factory, one in the center line of the factory, and then these orange cross beams which will form the ceiling, and then I can put a mezzanine above it as well and basically double my floor space. So I'll gain all of the floor space of the clean room, and then probably sling another bit of mezzanine off to the side as well. So I'll gain even more than, so I'll probably get about 70 square meters of floor space up on the mezzanine. And these are now all sitting, these orange cross beams are now all sitting just inside the roller door, just through the wall from me. Now, where are we? AirTag Pi. Oh, Michael says I have my .au as well. Yeah. Oh, cool. Martin says, I'm sorting my garage, partly inspired by your lovely workshop, John. Well, thank you. I'm going to line it with plywood so I can create a French cleat wall. That's really handy. So for those of you who don't know what French cleats are, they are a neat way of hanging things. French cleat. They're often used for things like hanging TVs or heavy stuff back here. So this is a sort of thing. So the idea with a French cleat, where's a picture? Okay, so you can see here that the cleat wall has horizontal strips, and the strips have like a 45, where are we? So this is the wall, and then the cleat has a 45-degree angle on it so that you can hook things onto it and it stays very secure. Actually, you can get a better view from there. So there you can see the idea of a French cleat. And then you put a matching thing on the back of whatever you want to hang from it. And then you can just hook things onto the wall. It's a very cool way of making a wall that is all reconfigurable. And then you can put different things on it and rearrange all of your fittings. Michael says, more highly engineered picture rail. Yes. Henrik says, can we do something electronical? Absolutely. That is actually my plan for today. I even have stuff set out here to do something electronical. So, Henrik, I know you get frustrated when I sit here and talk about random things, and I do want to do something electronical today. No, Peter said no. What was that about? No. No. I don't get it. Okay. I don't know what you were replying to, Peter. Yes. For tracking Austin if he travels to Australia. Right. Mike asked, advantages over Pine standard construction. Alright, so before I get into the electronical stuff, I am just going to finish off this quick thing. So there are a couple of advantages. One is, well, the cost seems to be very good, and that is partly because of speed and less labor required in building it. To do construction with traditional methods, like just building a stud wall, it's labor. There's a fair bit of labor involved. There's a bit of materials cost, but there's a lot of it goes in labor. It's cutting all of the stuff and nailing it together and all that sort of thing. Whereas with Dexian pallet racking, as Lachlan and I demonstrated this morning as we started putting his thing in place, a couple of people for a couple of hours and you can build like a big structure, and it's all done with long span beams and very high load ratings and pre-certified structural materials and all of that sort of thing. So it's extremely quick to put together, and you can build really big things really quickly, really big, really strong things really quickly. And then if it turns out that you want to reconfigure things, like you want to move walls or something, you can just unclip the beams and move the uprights and clip them all back together, and it's all reconfigured. So it's not quite that easy, of course, once you've got lining or something in it, but still it's a very cost-effective way to do it. And because pallet racking is kind of like the universal construction material in factories, it's really easy to get secondhand. People buy it and sell it all the time. If people want to reconfigure their factory, they might get more different pallet racking in for different lengths of beams or whatever, and then they sell off their secondhand beams or uprights. So you can, just within walking distance of where I am right now, there are heaps of factories full of Dexian pallet racking, and there's a dealer directly over the back fence, like around the other side of the block. So it's super easy to get. Yeah, the universal thing. Gavin said you are dyno bolting into the floor for stability, right? Yes, that's correct. So there are standards that you have to comply with, and that in the Australian standard currently requires 2 bolts into the floor on every foot location. And I think, and there's a subtlety to it, like you can't have 2 bolts on the same side of the foot or something. It's got to be on opposite sides. I can't remember the exact details, but yes. So it ends up being incredibly strong and dyno bolted into the concrete slab. Yes, okay. Todor said, haven't been here for a while. Is the Access Point PPSK project still going? Yes, it is. It's just been on hold for the last few weeks while other things have been going on. And I want to get back to that. And also because I kind of wanted to give people a break from it. I'd done, it was like a month and a half of doing not much but talking about the Access Point. And I know there are some people who are super keen and really want to keep going with it. And for other people, it's just like, who cares? So I thought I would just take a break from it for a little while and do some other things. So Don says, a job for a large Hilti. Yes, I have a large Hilti. Hiltis are great things. Very, very handy. They, yeah, a Hilti with a good bit will go through cement like it's hot knife through butter. They're amazing. Yeah, Tony says, be careful when you buy racking. There is the Colby brand, which is not compatible with Dexian. Locking method is different. Yeah, there are several competing types, and there are some. One of the things that can be a real problem is that there are two types that look almost identical, but the shape of the slots is a little bit different in the uprights, and the spacing between them is off by 2.5 millimeters vertically. So you can glance at it and go, yeah, that is right, but it's not quite right. And the thing is that if you've got, hang on, I'm going to show you Dexian palette connector, maybe, yes, okay. So what you can see here is an example of how the beam locks into the upright, and you can see that in this case it's got four little, where's a different one? Oh, this one. So this one's got three. There are three little hooks, and those hooks engage with the slots in the uprights, and yeah, this, and so it hangs on those. If I go back to this one, you can see that the force is being transferred through these tabs. This is all of the force from the beam to the upright is being transferred through the tabs. So you've got, in this case, three tabs sticking in which engage with the upright. Now the thing is that if you have the wrong type and you get the one that is 2.5 millimeters difference in the spacing, instead of the load being carried by all three of those tabs, it'll be carried by one of the tabs because the others will be slightly offset. So it can potentially be quite dangerous to use the wrong type. So you've got to make sure that the type of lock mechanism is correct for the type on the beam is correct for the type of upright. You can't mix and match. So yeah, anyway. So Tony S is absolutely right. Tony Smith says, have a warehouse 50% Dexy and 50% Colby. Ah, right. Yeah. Oh, Henrik said, I sent you a link in Discord. It's a kit and I'm asking if it's okay, what you think it's worth it to buy. I'm a hobbyist electronics, so what do you think about it? Obviously, if you have time to look at it. Okay. Henrik, I will have a quick look. Mr. DIY, hey, thank you for coming along. Let's have a look at Discord. And then I'm going to get into the actual electrons stuff. Where is this kit? This could be interesting for other people as well. Okay, there's an AliExpress kit. Open here and let's see. Let's get people's opinions on this. So, Henrik wants to know if this kit is worth buying. All right. So it's an IC assortment, 150 pieces, op amp, oscillator, PWM 555. So it's got timers, it's got various bits and pieces in it, and it's 18 bucks plus shipping, so 30. It'll be different to where you are, obviously, Henrik. But what have we got? I tend to be okay, I will give my thoughts on this in just a second. But first I want to, my general thoughts, first I want to see what is in this. So we've got photocoupler, AC one, yeah, optocouplers are useful, 20 pieces of them. More than you'd need just for an experiment or two. Not enough for producing quantities of anything. 2555s, that can be interesting. Some op amps, some comparators, and more op amps. LM386M, so it's a low power audio frequency amplifier. Okay, so you can make a little audio amp in a pentawatt package. TO220, okay. Little audio amplifier, high performance current mode controller, transistor array. Okay, so my thoughts on this pack. I personally probably would not buy this. So here are my thoughts, the reasoning behind this, and I'd be interested to know Oh, yeah, Tony said, there's a spring clip that stops rail lifting out. Yeah, that's getting back to the Dexian pallet racking. That's right, yes, there is a clip that goes in. I'm going to try not to get back onto the pallet racking subject, because I'll keep talking about that until 12, and I want to get some electronic stuff done today. Now, I am a fan of packs or kits for things like resistors and capacitors, and they are very, very useful. For example, I've got right here, I've got an 0603 resistor pack, I've got an 0402 resistor pack. I won't drag them out, but I've got an 0603 capacitor pack, an 0402 capacitor pack. The reason that those sorts of things are useful as packs is because, well, a couple of reasons. It's very cheap to have some of every single possible value of resistor, for example. And it is the sort of thing where, as you're building a circuit, you might build a circuit and it calls for an 82k resistor for some reason. I don't know, it's got a voltage divider in it or something. And sourcing a single 82k resistor can be a pain. Like if you've got to order it, or if you've got to go down to the shop to buy it, then that's a whole lot of expense. But for not very much money, you can buy a pack that has every single value of resistor in it. So then at least you're covered for your general experimentation needs. Now the thing is that what we're talking about there is a pack of things that are all the same function. So it's all a resistor. It's all resistors, just different values. And that is very useful. But when it comes to things like these, like a pack of op amps and comparators and various things, those are the sort of thing where generally you would give a lot more thought to it in your circuit design, and it's going to be dependent on the specific requirements of the circuit. So the thing is that apart from precision and power ratings, a resistor is a resistor. You can use it in all sorts of different circuits. But for example, if you well, this is a useful and pretty common one, but like an LM358 low power op amp, if you have a need to design a circuit that uses an op amp, then you're going to have specific requirements. You're going to have certain needs in terms of gain and whatever else, and voltage range, and whether it's rail to rail, and all of the other characteristics of an op amp. And you can't just necessarily just substitute one for another. So if you are working on if you're assembling someone else's design, say someone has designed a circuit that uses an op amp, they're going to specify what that op amp is. And generally, you need to get that part. You can't just go, oh yeah, this is the next closest thing, so I'll substitute it. Sometimes you can, often you can't. So what would end up happening is that if you buy this kit, you end up with 150 ICs, and almost all of them you will never use. You might end up using a couple of them at some point. Things like 555s are very common. Photocouplers can be useful in certain situations, and a basic op amp can be useful in certain situations. But I bet that if you bought this kit 5 years from now, almost everything would still be in the pack. You would have used only a couple of things out of it. So I'm not a big fan of this sort of assorted pack. Yeah, well, Mr. DIY says, I agree, I'd rather save my money and spend it on fast shipping to get the one part I need right now from Amazon Prime or DigiKey. Yeah. Okay. Yes. So, now there is an exception to this. The particular focus of this pack seems to be very much around analog stuff like the op amps and comparators and a couple of audio amplifiers. So if that was your particular area of interest and you were wanting to experiment with op amp circuits and learn about how they work, look up tutorials on them, then perhaps spending the 19 euros to get this kit is fine. It's not a problem. And 19 euros is not really a lot of money. So it's just a question of, if you discover that you only ever use a couple of 555s out of this and the rest of the kit is wasted, then you spent 19 euros on a couple of 555s. So, and you would have been better off just including them in your next parts order and spending, how much is a 555 these days? Like 10 cents? 20 cents? I don't know. I haven't even I haven't looked at 555 prices for ages. Yeah, just buy them if you need them. So my attitude towards ICs is buy them as you need them. Don't just buy them speculatively. And my attitude to jelly bean parts like resistors and capacitors is buy a pack or a kit, and then as you start using certain values, buy them in bulk. And the thing, so if you end up doing surface mount, for example, you can buy a reel of a value of, like, say, standard ones, like 10k resistors, 1k resistors. You can buy a reel of 5,000 resistors for like $4. So the ones that you discover that you go through, buy a reel, solve the problem permanently. Never run out of that value ever again for the rest of your life. Unless you're running a pick and place machine, in which case, and building boards, in which case you go through reels and reels and reels. I'm talking about just building projects on the workbench as a hobbyist sort of thing. Yeah, buy a reel, solve the problem for life. Yeah, Mr. Fixit said, I have asked on several occasions what parts would be best to have for a starter kit, starter lab, i.e. the most used resistors, caps, etc. Yeah, okay, so to summarize my thoughts on that, I'm just going to find something that I can show you. And also, there are two different parallel approaches here, depending on whether you're going for a surface mount or through hole. I find that I almost never use through hole. Even for prototyping, I use surface mount. Like if I'm prototyping a circuit and I'm not doing a custom PCB, I will usually do that on a proto shield, and then I just put surface mount parts between the pads on the proto shield. So I will show you my approach to how to deal with this. What am I looking for? Resistors. Where? I don't even know where my pack of resistors is. My somewhere around. This shows. Where did it go? Where did it go? It might be out in the other, out in the factory area somewhere. But what I did was I bought one of those mixed resistor packs. Sorry, all you can see is my butt walking around. Special treat. I thought it was just up here, but it's not. Okay, while I'm up walking around, I'm going to grab something else from around the back of these shelves. Reels. Okay. Reels. So this is just a couple of examples. Okay, so this principle applies whether you are dealing with either surface mount or through hole. It's the same process. I'm just going to show you the through hole process, but the same thing works with, I'm going to show you the surface mount process. So step one, buy a resistor kit. So in this case, I've got a surface mount resistor kit. This is my 0603 pack, and inside it has many values. Ta-da! So it's not actually every single possible value within that range, and there are different precision ranges and things. But it's enough. It's most of the values that you care about. So if you've got a design and you have something that says you need a 560 ohm resistor, then here I've got 511, 562, 590. So grab the 562 ohm, it's probably close enough. And it'll get you most of the way there. But then, and that is a really good way to do it. So instead of just buying individual resistors to create your starter pack or your starter lab, I would buy a resistor kit. And then what you'll find is there are certain values that you use all the time. So in digital circuits, those values are typically 1K, 4.7K, 10K, and then often something higher like 22K or a 47K if you want weak pull-ups. But the vast majority of the things in your circuit are going to be that. So in this particular case, this pack was 144 values, 100 pieces per value. So what was that? 14,400 resistors. Yeah, 14,400 resistors in this pack when I got it. But then there are certain values, that, like those ones I just mentioned, that you will run out of really quickly. And when that happens, what do? You buy a reel. Where's a... My 10K thing is empty because I put the last reel in the machine. But just as an example, like this is, it's a reel of 8.2K resistors, and it's 5,000 on a reel, and this reel would have cost me $4 or $5. So then you buy the values that you want, and then that is solved. That problem is solved for life. And you can strip some out of the reel and pour them into your resistor kit and top it up so that you're replenishing the ones that you go through all the time. What I was looking for, there it is. Okay, I found it. Okay, so the same principle with through-hole resistors. It was hiding behind, it was just up on my workbench, but it was hiding behind my, I think. So, this is my through-hole resistor kit. And what I've got is, for example, at the front, 0 ohm resistors, and there is a little strip that can come off the bandolier type thing. So I've got however many it is, 0 ohm resistors, and then behind that, what's that? 1.2 ohm resistors. So a pack like this, it's the same sort of thing as my as my surface mount resistor pack. It's just, this is almost every single possible value of through-hole resistors. And you can buy a pack like this very cheaply as well. So if you want to go for the through-hole route, buy a resistor pack, and then once again, where did it go? There it is. If you discover that there is a particular type of through-hole resistor that you use a lot of, woohoo, buy a bandolier. So what is this one? This is, where's the value? Where's the value? 4.7K, okay. So this is a strip. I've got to find the end of it. Here we go. So this is a dispenser box of 4.7K resistors, and how many are in that? 5,000. So this is 5,000 4.7K resistors through hole. Same sort of principle as the reel, it's just that it's in a dispenser box. And these dispensers are used by machines for machine loading of parts. But if you find there is a particular value of through-hole resistor that you use, you can go and buy a pack of 5,000 of them. And once again, solve the problem for the rest of your life. Never have to care about it again. Yes, Sion says, my most used 0 ohm, 22 ohm, 330 ohm, 1.2K, 2.2K, 3.3K, 5.1K, 10K, 100K, 160K, 442K. Yep, cool. Very useful information. And for capacitors, Sion says 10 nanofarad, 100 nanofarad, 1 microfarad, 2.2 microfarad, 10 microfarad. Yeah, I totally concur on the capacitors. That pretty much lines up with what I use as well. What you'll find is that you end up using 100 nanofarad capacitors like confetti. They just get sprinkled through circuits for power decoupling. 10 microfarads similarly, like on the output of voltage regulators and different places like that. And then other values like 10 nanofarad and 1 microfarad in other places. So yeah, Sion pointed out, okay, this is definitely worth keeping in mind. Okay, so Sion said, also keep in mind the caps and resistors you get in the cheap sample books are usually really crap quality, meaning bad tolerances and poor dielectrics. Yeah, so they're not going to be the greatest things ever, but they at least give you a starting point, and they give you the full range. And then when you find the ones that you care about, then you can buy those directly and get exactly what you want in the quality you want. I'm just going to move some stuff off the bench here over to there. I'm deferring that cleaning up problem to later because I want to show you some stuff on the bench. Now, just got to get out of Discord and close that. All right, what I want to, oh yeah, just in passing again. So there was that comment earlier, I think it might have been Tony. Someone pointed out that there are clips that hold the Dexian beams in place. So you can see just in here, what does that icon do? No, I don't want to do that. I don't even know what that does. If I hover over it, does it give me a tooltip? No. What is this function in Google Images? I don't know. So yeah, there are these little clips. So you drop the pallet in there, a cross beam, then you put the clip in, there's a pin that goes through so that you can't then lift it back out again. And that helps with things like if someone hits it with a forklift and tries to lift it, it's not going to come up out of the pins, or if there's an earthquake or something, you know, whatever. It just makes it a more permanent installation. So what I want to do today is, Sion said, I was meaning those black books on AliExpress. The box kits are better as they give you the part specs. Yes. So I have, where are they? Oh, I think I actually put them away. I do have some of those little, you can get black books. Now, because this is actually worth sticking with just for a moment, I'm just going to bring this back up to show everybody what Sion is talking about. I have some of these, and they are currently like in a box in storage in the factory somewhere because I don't even use them. AliExpress. Scott says the clips guarantee unconsciousness when you bash your head on the bottom, on the beam. Now, what am I looking for? Say resistor kit book. That'll do. Yeah, this sort of thing. So this, well, this is a actually this is not too bad. This is a little book. They're typically quite small. They're like A5 size. You open them up and they've got all those plastic sleeves filled with whatever it was you bought. Like it could be through-hole resistors or surface mount resistors or whatever. This one is a resistor book for through-hole resistors. So you just flip through it and find the part that you want, pull it out, and it's got all the labels and things in there. Now, the ones I've got are more like this. These are, it's got little sleeves in it and strips of surface mount parts, and then you can pick the size you want, like 0603, 4,250 pieces, 170 values. And yeah, you just flip through, find the piece you want, pull out the tape, extract however many you need to use for whatever you're doing, and shove the tape back in. And then over time you'll find that some of these you just use up quickly, and then you need to buy more of that particular part. But it gives you everything you want right there. So that is the type that Sion was talking about, which can be a bit of hit and miss quality. Yeah, and also I just don't find them as convenient as the ones like I've got, which are the plastic tubs that open up with all the little compartments in them. They're much more convenient to use because you don't have to pull the tape out and peel it back, and yeah. Yeah. Oh, so Sion said those books are better than my older ones. They state tolerance, which is nice. Yeah, that's right. At least these claim to be 1% resistors. So I don't, yeah, who knows if they really are, but that's what they claim. Right, so so going all the way back to Henrik's original thing, if you were wanting to get some things to help you get started, I would rather spend 20 bucks on a resistor pack, a resistor kit, than to spend 20 bucks on an assortment of ICs. This is more like your everyday bread and butter. This is the stuff that you will be using constantly, whereas the ICs are specialized for particular purposes, and you need to buy what you need, not just buy things randomly and hope that it's going to be useful in some way. So where we are going, okay, I want to characterize the MCP 23017 problem. Mr. Fixit asked, what size do you mostly use for your SMT? For me, I use primarily 0603, and Sion, I'm pretty sure, uses 0402 primarily, with some other sizes. Stephen W. just said 0402 these days. Yeah, the reason I stick with, I've been sticking with 0603, yeah, I've used different sizes. I've done a few things, like the ArduSat boards, for example, I did with 0402. I've done a few boards with 0402s, but with my pick and place machine, so with Mick or Make It, which is my homemade pick and place machine, 0603, it can put down pretty much all day without a problem. 0402, yeah, I would have problems with alignment with the 3D printed feeders and getting them into a consistent pickup location, and you could probably do it, but I would spend all my time sitting there nudging all the parts back into place on the board. So 0603 is just a comfortable thing, and my situation is probably a little bit different to Sion's in terms of design requirements or objectives. So I know that Sion is obsessed with making things small. The smaller the better. So jamming everything in, making everything really tight, maximizing the use of board space. And that isn't really, most of the time that's not a consideration for me. With the kinds of projects I do for things like my industrial clients, the bigger concern is things like heat, and not that the board itself is going to be generating heat, but just that it's going to be subjected to extreme conditions. They're going to be put into very high temperature situations and nasty things. So yes. Oh yeah, this is a good point. Sion said larger value caps have poorer characteristics as the packages get smaller. Yep. That is just a result of the way capacitance works. And yes, I know Sion already knows this very well, but I'm not going to get into that. Capacitance is all about proximity of surface area. So you run into physical limitations as the packages get smaller. Like, you can make a smaller package, a very small package, with almost any resistance that you want. All you're doing is compromising your power rating. But as you go smaller and smaller on capacitors, you start running into geometry problems because you just can't get enough surface area of the adjacent plates to form the capacitor. Yeah. Mr. DIY, oh yeah, this is a good point. Mr. DIY said, I discovered 0805 fit 0603 standard pads if you really have to. Yes, it actually works basically with every increment. Whatever the pad size is that's on the board, you can fit one size up or one size down. So if you've got 0603 pads on your board, you can put an 0402 on it and make it work. You can put an 0805 on it and make it work. And you know, if you put 0402 pads down, you can jam an 0603 on it, kind of, and you can put an 0201 on it, kind of. It's tricky and a little bit fiddly, maybe a little bit of jiggering around with the solder, but you can make it work if you have to. Yeah, physics sucks. You're right, Sion. Yeah, Stephen, when you're primarily working with 0402 and have to put in an 0805 part, it looks huge. Yeah. Yes, it all becomes a matter of what your eyes are calibrated to. So, now, MCP 23017. What is the time now? It's 10:53. There's going to be a bit of stuffing around with this because I have not done a whole lot of preparation. I've just pulled out some things and let's just make it up as we go. So, the very brief background. There was an update to the datasheet from the microchip MCP 23017 which said not to use the high bit as an input. And if we go for yeah, I could explain a whole lot of background now for the people that haven't heard it before, but I'm sure many of you have heard it, so I've got to fit that balance of how much do I say versus how much do I not say. Alright, so the very brief explanation is an MCP 23017 is an I2C based I/O expander. It has these three address pins, oops, A0, A1, A2. It has clock and data for I2C, so I'm talking about the I2C version here, not the SPI version. And then obviously power pins and some interrupt stuff that we don't care about right now. So what it allows you to do is have two 8-bit ports. So we've got GPA and then we've got bits 0 to 7, and we've got GPB and bits 0 to 7 once again. And what you can do is, communicating with this over I2C, you can set each of these pins as either an input or an output, and you can also turn on input pull-ups. So you can treat this as a whole lot of extra I/O pins for your project. So if you have a microcontroller and you want to have extra I/O for buttons or sensors or whatever, and you've run out of I/O pins on your microcontroller, what you can do is add an MCP 23017, just connect it to I2C, so you only need the two pins on the microcontroller, and if you've got other I2C devices already, then you're already allocating those pins. It really doesn't matter. So essentially you gain extra I/O for free. There's no, there are limitations obviously, but that's the general principle. We've got a whole bunch of these I/O pins. And these chips are what are used in the OXRS light switch controller boards, and I've used many of these chips over the years. Some, like a lot. I've bought a lot of these, and on some of the boards, well, here's an example because we're going to be using this one in just a second. This is the light, one of the light switch breakouts, and you can see here it's got 6 of the MCP 23017s on it, and then each of those gains us 16 I/O pins. So it's 6 times 16 extra I/O ports, all connected via an I2C connector, and then broken out onto these RJ45 sockets, which then go out through cabling through the house to light switches. So this is how we can use a microcontroller with just an I2C connection to read the state of all of those light switches all throughout the house. And so the big issue is on this chip. So you look at that chip right there, and then we switch back to here. This is the chip that we're looking at right here. I am using all 16 of the I/O pins on this chip on this board, on all 6 of those. And I've got a version of this board which has 8 of them, because there are 4 of these sockets instead of 3. So the board is longer. It comes out to here somewhere. It's ridiculous. The whole PCB is like yeah, it's a ridiculous board to try to load. It's so long. And so, oops, that's what we want. Now, this is where the thing comes in. Peter says it's nowhere near lunchtime, but it's closer now than when I started writing the sentence. That is true. So Stephen said alternative is a TCA 9555. Yeah, there are quite a few I2C I/O expanders. It's just that this particular one is the one that I've been using for many years, and I would like to keep using it except for this problem. So what you can see here, when I talk about high bits and low bits, so you can see on port B on the left here, we've got bit 0, 1, 2, 3, all the way to bit 7. So bit 7 is the high bit. And on this pinout, you can see that it is shown as both an input and an output. It's bidirectional. So each of these pins we can configure to either drive out to turn things on and off, or to read in to check the state of something. And what was discovered not that long ago, well, people started seeing this problem years and years ago and complaining about it on the microchip forums, and didn't really get any clear responses. But what happened was that people noticed that on the high bit, so on GPB7 and on GPA7, if you use this as an input and you send a changing signal into it enough times, statistically at some point you get phantom reads off other inputs. So there is something going on inside the chip, like either a silicon bug or a firmware bug in the chip, which means that triggering input bit 7 will cause false triggers on other inputs. And that is a problem in the context of the light switch controller, because what that means is that, say you've got light switches wired around your house, and this input bit, so bit 7, GPA 7, is wired to one of your light switches, and then you walk up and you press that light switch. It is possible in some circumstances for other inputs to also be triggered, and then your automation system will think, hey, both of those switches have been pressed, and you'll press one switch and it will turn off a totally different switch, a totally different thing somewhere else in the house, depending on what it was that you were controlling. So that is a problem. And Microchip released an update to the datasheet, and the update basically just said, don't use bit 7 as an input. So the controversy is, a lot of the issue is, did they make a change to disable the input on that, or did they simply change the datasheet to acknowledge a problem that already existed? And I'm pretty sure that Interesting. So Tony said, on existing chips, we understand that bit 7 input can cause problems with bit 0 to 6, and so it's not recommended to use. However, bit 7 of the new silicon no longer works as an input. And immediately after that, Austin said, only a datasheet change. Okay, so we have those are two contradictory things. And I don't know what's right. This is the thing, is that I don't know. I know there was a silicon revision, but I don't know if they specifically disabled it. Like if someone has the most recent silicon, can you use bit 7 as an input? Or does it simply refuse? I don't know. So I think the best case scenario for us here as users of this chip is that they have not deliberately disabled it. They've just left the silicon as it is, or they haven't actually gone out of their way to stop that being used as an input. They've only noted in the data sheet that you shouldn't use it as an input, but you still can. Because what that means is that we can do workarounds in software, like multiple reads to detect whether there is a false trigger going on. For example, the logic in software could be, if you get a read off, well, you could either do averaging. It depends on how this characterizes itself. Whether an input on this causes false inputs on other things that remain asserted until bit 7 is no longer asserted or whatever, in which case an averaging algorithm would not work. Or is it, yeah, there could be a thing, for example, where if you read that one of the other inputs has been asserted, then you check if bit 7 is also asserted, and if it is, then you ignore the other input, the one that isn't bit 7. So there are nice, but that means that you're going to miss situations where both of those inputs are legitimately being asserted simultaneously. Yeah. So a bit of jiggery-pokery. It's possible that we can work around this in firmware. But anyway, I want to see the problem for myself. This is what it comes down to. I've been reading about this. I want to see it actually happen. And that's what I want to try to do right now. So let's see if we can make it happen. I'm going to... oh yeah, Mr. Fixit has another suggestion from Texas Instruments, the PCF8575. Remote 16-bit I2C and SM bus I/O expander with interrupt output. Yeah, pretty much compatible with this. And there are other solutions as well, like Serial Wombat, which I've talked about on previous streams. So yeah, there are multiple solutions to this. But right now, I want to see the problem for myself. The solution comes later. We can talk about that. TI made and much cheaper. Ooh, okay. Both of those things sound intriguing. Now, my plan is, let's switch over to here. All right, now the reason I pulled this out is that this has a whole bunch of these MCP 23017s on it. Then I have here, caught in the solder, a rack 32, which we can use to read it. And then, what else do we have? I have a function generator, so we can use this to send a square wave into one of the inputs on this, onto one of the high bit inputs. We will read it with this, and we'll see what happens to the other inputs. So, where to begin? Hang on, I've got to move. I've moved stuff around on my bench and made a mess in order to get to that resistor kit. All right, now let's start with some basics, really basics. We need to get some firmware onto this that is just going to read the values coming into this and output it on the console as fast as possible. Probably in some kind of a binary format is the most useful visual representation, I think. So what do we want? We want an I2C connection from there to there. And what have we got? We've got address pins, we've got pull-ups active there, pull-ups active there. So let's just pull those off. We want some power. I think we only need, I don't know. I'll plug in a bench supply. I haven't really thought this through very well. I will plug in a bench supply if I need to. For now, I'm going to get some USB onto it. So USB to plug into the Rack 32. And then we can do some messing around with the, oh yeah, you can see we've got logic power on here. We've got the Rack 32 alive. I'm going to do some, like a hacky version of the firmware, just to scan that as quickly as possible, and to show us what is going on. Delane, hey, welcome. Thank you for coming along. Yeah, Mr. Fix-It said, I just want a part that I can buy. Tired of shortages, real or imaginary? Yes. Yes, aren't we all? Now, where am I looking? Projects. I'm just going to pull up something to use as a starting point for the firmware. Where's the LSC, light switch controller, firmware? Arduino firmware. So I'm just going to do this. Firmware. Let's just do that. Yes, I know this is hacky. This is nasty. And now you're going to all get to see me, see how dodgy I am when it comes to messing around with firmware. I'm trying to get something working. The IDE is opening slowly. Okay, hang on. It's drink time. Drink time. All right, the IDE has opened. What have we got here? LSC Rack 32 light switch test. So this is not the proper OXRS firmware. This is based on one of the earlier firmwares that before the whole OXRS infrastructure was was put in place. But I figure that this is probably a simple thing to use as a starting point. Simple. Does a whole lot of stuff that we don't need. All right, so MQTT. I'm just going to go through and hack this. PubSub client. This is going to cause errors everywhere. Button click handling, LCSC button. I'm not going to use that. So the light switch controller button, and this is part of something that ended up being abstracted out. I think, who did that? Was it Moyne? I'm not sure. Yeah, this is all now part of the OXRS code infrastructure. Wi-Fi client, no, we don't want Wi-Fi. By commenting out the includes here, it will give it'll give compiler errors when message buffer. Yeah, let's just get rid of these because it's going to give compiler errors when I try to compile it if I've forgotten to disable stuff later on. So that'll do for now. LCSC button. Let's not use that. We're going to keep the Adafruit, keep this MCP 23017, max MCP count. What have we got? PubSub client, get rid of that. And device ID, don't care, that shouldn't cause a problem. Let's just get rid of Wi-Fi entirely. MQTT, get rid of that. This is a real just hack and slash job. Get rid of that. Yeah, don't need MQTT. Scan the bus. Set up Wi-Fi. Screw that. We don't want Wi-Fi. Don't want to report Wi-Fi status. Loop. Okay, enable, get rid of MQTT there. Get rid of Wi-Fi. And reconnect MQTT. Don't need that. It's not even going to be called, so it doesn't matter. Don't need the callback. Get rid of that. And Now, this will be broken at the moment because the, where is it? The call to this will be broken. What else do we have in here? Button pressed. Oh, this was the old style handler for it. Scan I2C bus, that's okay. Michael said, I just saw an RPi Zero on AliExpress for 132 Australian dollars. Oh, wow. Yeah. Ooh, Mr. Fix-It said, yeah, this is one of those areas where we can start getting, we can start becoming protective and competitive of the information. Mr. Fix-It said, I did a comprehensive search for options last year. I need to look up my best pick. Yeah. Now you're in the situation where you were probably thinking, done the research, he knows what is the best thing to buy, what is the best alternative to buy, but do you share that information publicly and then risk having other people buy out the stock of the part? That could be dangerous. Dentistries, hey, hello from the UK, what have I missed? A whole lot of talk about Dexia and pallet racking, mostly, plus a bit of talk about I/O expanders and things. So what am I doing? Button press, button handlers. This is going to, what have I got it set for compiling for? ESP32 dev module, that'll do. Oh, and that's the port. I'm just going to try compiling. It's going to fail. We'll get a compiler error here. Absolutely guaranteed 100% because I've disabled the button library, but I just want to see where the failure is. Not enough random. Yeah. Oh, sorry, Chip. Yeah, that's it. That failed exactly where I thought it would. So button, yeah, reading the button events. On button pressed. Where are we? Scan I2C bus scanning for devices. So I'm going to just get rid of that. And pin mode, pin input. What we want to do, I don't know if it's going to make any difference. This particular board, okay, when people have been seeing this problem, it is when they are setting the pin to input mode and enabling input pull-up. Now, I don't know if the input pull-up has any particular relation, any influence on this problem. I don't think it does. But I've got external pull-ups on, like hardware pull-ups on this board. So on this right here, you can see the little resistor arrays next to each of the MCPs. You can see lots and lots of resistor arrays, and those are input pull-ups. Well, it's a combination of an input pull-up and a series resistor. That's why there are pairs of arrays. It's a 10K pull-up, I believe. I can't remember. Yeah, 10K pull-up, and then a 1K series resistor. So we don't actually need to turn on input pull-ups. We're just putting each of those into input mode. Now, I want to simplify this and goodly specific and interesting though. Yeah. Oh, okay. Brief break for chasing squirrels. Scott says, haven't seen Steve yet. Steve is still here. Where is he? Steve is here. So here is your weekly dose of Steve. And Steve says, hey John, are you going to restock Freetronics products, in particular the 8 relay shield? Yeah, that one is one that I really do want to get back in stock because it's very useful for all sorts of automation projects. The short answer is yes, but it's really not economically viable. The thing is that Freetronics now is selling so little that the cost of things like paying for the online store fees and bank fees and all of those sorts of things, insurance is crazy. The amount of insurance that I'm paying, how much is it? I think I'm paying something in the order of $10,000 a year in insurance I might be off by a few thousand on that number, but it's something like that. And yeah, so when and the sales velocity is so low that if I fabricate a couple of hundred relay boards, it could take years to sell them. So it's just a tricky situation. What am I doing? That's right. I was looking at this. So let's simplify this dramatically. If I is less than max, bitrate G, let's just go more of the hack and size of I2C address. I just want to get rid of most of this. Let's go for MCP pin mode, blah. I want to get rid of the loop. So let's go for, what is the first address? Hang on, I'm going to pull this off screen temporarily because I know that there are Wi-Fi passwords and things in here. The first address, oh no, it's not defined in there. That's okay. The addresses are defined here. 0x20. Let's just use the first one. Okay. And bringing this back into your view. So we've got, going right to the bottom, scan I2C bus. I don't even know if we want to, do I want to change this? I think I do want to change it. I think what I'm going to do is that. So it does scan, does that, y.begin transmission, and if while in transmission 0, I want to grab that. And I'm going to get rid of this function entirely and just do it in setup. Where are we? Setup. Blah, 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 blah. Scan I2C bus. Yeah, at the moment it's calling out to scan I2C bus. I'm just going to do this, which is, no, get rid of that. Too much indentation. And I'm just going to hard code stuff. So I'm going to go for port 20, 20, hex 20 rather. So if the transmission is not ended, and then we'll do begin I2C, and then that's going to be 0x20. That's not going to be an array, it's just going to be a thing for uint blah pin count. That's pin count is 16. Although we don't really care, let's just do it to 8. I'm just going to take it off the first port. So pin mode, set that to that. I'm going to have to redeclare MCP 23017 higher up. And let's get rid of that. What are we doing? Scan. All right, separate that down. So this is now the bit that we care about. So where was MCP 23017 declared? Back up here somewhere. Yeah, we don't even care about that anymore. Max pin count 16. Don't care about that. We're not using it. Not using that. Yes, I know I don't really need to delete this. I'm just deleting it because it just simplifies things in my own brain. Values, whatever, that can stay. I can stay. I want, oh yeah, let's do it this way. We'll make that, what am I going to do here? Max MCP count 1. max, which means I'm going to have to change this back down here to that and that. Oh, I don't really need to be declaring this as an array, but who cares? What have we got? Okay, so now iterate through it. Max MCP count. No, I just want to do if bit read blah continue. Oh yeah, that's just checking whether it actually exists. Then button 0 process. So this is where we want to read from it. So let's go 1. IO value. If 0 equals I serial, what is that? Let's just do this. Yeah, this is, all this stuff is IO value. This is where I should have thought this through a whole lot more before. IO values, IO value, don't care. Don't care. Port new. What are we using port new for? I don't know. We're not using it. Get rid of it. So, you're in 16. IO value is read GPIO AB. Is there a read GPIO function? Yes, there is. Cool. Okay. Then we've got print the IO value. There is something that is MCP read. No, I don't even need that loop. What am I doing? Simplify. Simplify. So in the loop, all we want to be doing is reading from that. Oh no, there are people. Addresses are at the top of the sketch. Yep, Austin says. Yes, I know there are people probably crying right now looking at my coding technique. So we are reading a value from that and serial print, but up here we are doing that equals begin that. We are setting each of the, no, let's do all there. Yeah, let's do all 16. No. I'm just going to use port A. Pin mode and pull up. Okay, so this is where we can set the pull up. It was disabled, but we can enable it. No, stuff it. Don't need it. 36 minutes, says Peter. Okay, got to get to connecting hardware together soon. Device ID, device ID, don't need that. Let's just hit compile and see how badly it explodes. I love compilers. I love the fact that I can, that it catches my problems and tells me all my mistakes. Because then I can go through and fix them. What is it doing? Okay, well, max MCP count not declared in this scope. Store values. Okay, yeah, we don't need that. Wi-Fi status reported. False, don't need that. Command topic, button topic, don't need those. Last message, don't need those. Compile. Let's just, oh, no, not that. Let's just try compiling again. Peter says there's a technique behind that code. Yeah, Don said you could ask ChatGPT to write. Yes. I really should have done that. MCP, pin count, pin, blah. Yes. That's because I removed that. Begin transmission, I2C addresses. I want to do 0 hex 20 on that. I2C addresses, 0, get rid of that. Oh no, I'm not even calling the scan function anymore, am I? What am I doing? That can all just go away. That's why that wasn't being referenced. Button pressed. Oh, that's probably going to cause problems as well, isn't it? Because MCP pin count I don't think is even defined anymore. Oh well. Yes. Exactly. At least I knew in advance how I had screwed up. Slash and burn technique. Chip, that's exactly right. Slash and burn. I'm going to be shocked when it gets to the point where this compiles. Even more shocked when it gets to the point where it does something useful. Hey, what? Hang on. Where are all the compiler errors? Oh well, what the hell? Let's just upload it and see what happens. Maybe the slash and burn technique has done something useful. So while that is compiling and uploading again, because it's got to compile twice, because the IDE is very annoying, it doesn't remember the fact that I haven't changed anything. So where am I doing the print? I've gone setup and then I'm doing print IO value. Okay, it's just printing the, it'll just print it in decimal. Hey, let's see what the hell is going on. Actually, what I should do is put a little, what I'm going to do, just for now, is I'm going to go serial.print millis. I'm going to end up, and then serial.print, just a delimiter, and then the value, and then I'm going to stick a delay in here. Delay, what do we do? 200 milliseconds, that'll do. And upload. Scott says, a bit late now, but could likely just add a debug output to the original sketch and run it. Maybe, except that I think it was there was a slight complication in relation to the button handler, and I didn't want to have to delve into that because it was setting up a the button object and then using the the object was handling it. So I would have then had to start hacking around inside the LCSC button handler to do the debugging. But what are we doing? What are we doing? Serial monitor. Okay. Whoa, look at this. We have milliseconds and we have a value, and 255 is what I would expect because it's an 8-bit port and all of the bits are currently being pulled high. So, how do I test this now? Okay, what I'm going to do is grab a light switch. Where do I grab a light switch? I need a light switch. That is the simplest solution. Light switches, I'm just looking at my box of stuff. Do I have it over there? Or I'm pretty sure my light switch stuff is out in the factory somewhere. So instead, yes, Stephen said, reminds me of that old, a new programmer compiles brand new code and gets no errors. It's working! An experienced programmer compiles brand new code and doesn't get any errors. Something's wrong. Yes. Yes. But amazingly in this case it does seem to be working. Although we don't know until I assert one of the inputs. Let's I keep waking up my voice assistant that I will not name. Hang on, I'm going to click the do not listen to me button. Alright, time to open up Iggy. Hey! Hey there, thanks for coming along to the stream. I'm just opening Eagle at the moment because I want to have a look at the connections on this. What I'm going to need to do to connect the signal generator output into this, I'm going to need to, the simplest thing is I'm just going to solder a couple of wires onto the bottom, which means if you have a voice assistant who should not be named, mute it right now. Alexa, turn on the soldering iron. Cool, done. So now, what? I hate this. Autodesk wants me to sign into my account to open Eagle. That is the sort of thing that makes me go, I want to switch to KiCad. Eagle. I've got to get my passphrase right. to decrypt the password, which I can't do while I'm talking. There we go. Okay. Decrypted my password. So if any of you heard my keystrokes then, you could probably figure out what the passphrase is to... Oh, and now it's doing two-factor authentication. All right, security code, come on. Security code is that. Save. Verifying. Projects, and it is I2C RJ45 hardware. What have I got? I've got the 24 port board here. It is this one. So top, that is a horrible view. Let's go for a single layer view. Okay, so here we go. GPA 0. Oh, you can't see it. I need to do that. So this, what we're looking at is, that is the same thing as that, just in virtual form. And what I wanted to do was find, so we've got GPA 0, 1, etc. coming down here to GPA 6, GPA 7. So this is the input that I want to screw around with to see if I can mess with its little brain and make it do bad things. So what have we got here? We've got the output that comes to this will be a 10K resistor array, and that is going to be, oh no, that's 1Ks. Okay, so 1K resistor array, if I use the show tool, GPA 7 goes through a 1K array, and the other side of that goes to the pull-up resistor. So this is to VCC, so 3.3 volts, and that'll be the 10K array, and then this is the actual line that goes down to the connection. So this is the suspect input that could be causing us grief. So what I want to do is solder on a couple of jumper wires. I have my little pack of random things here. What do I want? A bit of blue wire, a bit of black wire. That will do nicely. And I want to solder onto this and onto a ground connection. So the one right beside it is a ground as well. What tip do I have on the soldering iron? I have the way too big one. So let's go for the K tip. And I'll switch your view back in a moment. Let's do it right now. What have we got? I'm going to power this down, unplug that, and then the pin that I want, just looking across at the thing, is looking down through the board. It's the one on the front. It is further away, that's ground, that's signal. Okay, I think I've got it. So what I'm going to do is just prepare a couple of wires so I can put the alligator clips on the other end of these. And got to tin that one. Where's my solder? I moved it earlier. Solder comes back. Okay, go gadget soldering iron. You hot yet? Yes. Come on. I think I need to clean the tip of this iron. There we go. This one already had, it was already. Get out the Lindstrom cutters. I love these things, they're so good. Seems ridiculously extravagant to spend $70 on a pair of cutters, but I've decided they're worth it. The pain of paying for them has gone away, and now I am just left with the pleasure of using the very, very nice cutters. So I want signal coming off this one. I think I'm going to check this. I'm trying not to get my head in the way. That was not a very good solder joint, but I'm trying to do it with my head some distance away without getting it in the way of the overhead camera. So that goes on, come on, onto there. Now, is that solid? Seems like it. And that one should be ground. Let's just... Yeah, I was actually planning, I'm sure there are people in the chat right now saying, why didn't you just put some cable in an RJ45 plug? That was actually my plan, and I even got out the RJ45 plugs. They're somewhere around here. I've got to pull a bag of them out. And then right now I don't know where my RJ45 crimping tool is. It's in a box labelled Ethernet connections, Ethernet connectors. I'm not sure where that box is because everything gets moved. All right, what have we got? So I just want to make sure that I'm not screwing this up. So I'm looking across at on the screen you can't see. So bottom row, opposite side from that is ground, one in is GPIO 7. All right, so if we short these two bits of wire together now, what should happen is it should assert bit 7. So let's put all this back together, do the needful, plug that in. That's a, yeah, I need to not have these touch random things. Plug USB back in. So now we have that running, and if we come back to here. Now let's, well no, come back to, oh yes, that's right. So come back to here. But what I want is Arduino. Now, let's see if this is working. If I touch these wires together, does the value change? Amazingly, it does. Hooray! See, it's going to 127 and 255 if I pull them apart. So it is reading bit 7. But that formatting, I want to see this in binary. Can we do this as bin and then upload? Just because I want to see it in a more sort of visual representation of the individual inputs. I like playing around I like visualizing things in binary when I'm dealing with I/O like this. So, Trady Trev, yes, you made it. Yeah, Austin says, sounds like an excuse to get the box code scan system back in place. Yeah, I really want to do that. Yeah, Scott says, I'd have just chopped up a spare patch cable to connect the function gen. Yes, that's an option as well. All right, so what you can see there is we've now got binary representation of the 8 bits of the input. So if I now, you can't see this unfortunately, but if I short those wires together, you can see that it is changing the value, and that, I think we just saw a false trigger. Hang on, I'm gonna stop that auto scroll. Look at this. Scroll back to here. See, what was happening here is what I would expect to see. So we've got 8 bits coming in, the 8 inputs, and when I short bit 7, you can see that it drops down to 7, and I don't have padding turned on. So what it's doing is it's simply leaving off the first. That is a value of 255. That is a value of 127. And the most significant bit, which is bit 7, is on the left. So what's happening is that it's just getting shorter because all the digits are moving one step to the left. But look what happened up here. These inputs, it moved one step to the left because bit 7 was being asserted, but it was also asserting bit 1. See, from the right, that's bit 0, that's next one is bit 1, and I wasn't doing anything on bit 1. I think, even without barely trying, we have now just witnessed that ghost input problem. That is very, very interesting. Okay, But let's go one step further and stick a signal generator on it, and see what happens. What would be useful actually would be, what's an easy way to do zero padding? Maybe what I should have done is made it a uint 16, asserted the most significant bit. Scott says, now looks down and notices something laying on the board. Yeah, that is quite possible. But what we can do is, next step, coming back to the overhead, bring this little thing into play. Yeah, it's possible. There are little offcuts of leads and stuff on the bench from when I was just doing those patch cables a second ago. So it is possible there is something else that has triggered it. But that does seem suspiciously like the fault that we're expecting to see. So what I'm going to do is, what have we got? Output 1, channel 1, and so this is the function generator, and I'm going to connect this onto, hard to get it all in view at once. I'm going to connect this to ground and this to the input, and output voltage. Actually, I should check settings in this before I do any of this. All right, I need power for it. So this particular thing needs 5 volts. So I'm going to, I will turn on one of the bench supplies, set it to 5 volts and bring 5 volts in. What have we got? Okay, V set 5, go. It's set to 1 amp. That should do. Power. Turn that on, turn that on. Are you alive? No. Do I need to do anything else to turn you on? No. Oh, okay. It's hitting the current limit. Okay, that is a worry. I'm going to disconnect the output. Nothing but power connected to the function gen. It's turned off here. Oh, it says 5 volts, 2 amps. Why does this thing need 2 amps to run? I had the current limit on my bench supply set to 1 amp. Okay, I set to go. Power on, turn on. Do you work now? Yes, it's booting. Okay. So what have we got? We are set to 50 point, and then all of those zeros hertz. Is that 50 kilohertz or is that 50 hertz? I can't tell. That's weird. All right, channel 1, channel 2 is off. Don't care about that. Channel 1. So 5 volts peak to peak. Let's make it 3.3. So I don't even know how to do this. I've used this function generator like once ever. So square wave is fine. I want to do, I'll do amplitude, change that to 3. Actually, I wonder if I can just type it in. 3.3. Yeah, cool. So 3 millivolts. No, I don't want 3 millivolts. I want 3. I don't want to have to count up. All right, let's just do 3 amplitude. Nope. How do I get out of this? Oh, arrows. Okay. So, does anybody use one of these things before? Oh, okay. Millivolts peak to peak, volts peak to peak. Let's do, this value is out of range. Okay. Amplitude 2. Oh, come on. Amplitude. I want to set it to 3 volts. Let's just turn this off, turn it back on again, see if it went back to whatever the setting was before. It was set on 5 volts. When I turned it on, Yeah, it's now set to 2 millivolts peak to peak. So I'll go down to here, amplitude. What does the amplitude button do? 1, 2. It's just switching between two different modes. Oh, millivolts RMS versus peak to peak. All right, so instead of, now it won't go down below 2. That beeping, I'm sure, is annoying you, driving you crazy. Let's try, if it's talking about millivolts, let's do 3 volts peak to peak. Okay, so it's now 3 volts peak to peak. That'll do. That's close enough. Offset we don't care about. Oh, make it 3. Now let's make it 3.3. So offset, we want just off 0, phase, don't care, duty 11%. Let's, 11 is probably, no, let's make it 50%. Just make it a, yeah, that'll do. It's the down is when it's being asserted on the input, so that's what matters. So then, what have we got? 50 hertz. I don't know if that's 50 hertz or not. Let's just see. 50. If I take this up beyond the 100 point, what happens to the decimal point? Look at all the zeros on there. I'm not sure. It's got a decimal point there and then a comma there, which is very strange. 100 hertz. Anyway, I don't care. Let's just leave it on 100 hertz. That'll do for now. People were talking about seeing this problem when they were sending like a 1 megahertz square wave into it. But this will still give us something. So what do we want to do? Channel 1. And channel 1 should now be running. So what do we have coming up on? I should stick the scope on it just to check. Oh, hang on, I've got to do, here we go. Alexa, turn on the oscilloscope. Alexa, turn on oscilloscope. That's better. That's 100,000 million. Thanks, cable tie. Let's see if we're actually getting any output from this thing. So I've pressed the button on channel 1, but I don't even know if it's running. Let's get me a signal. Get me a signal. Come on. On there. Yeah, it is running. Okay, I can see it on the oscilloscope. It is doing a square wave. It is max of amplitude 3.2 volts, max of 2. Has it got a negative offset? It has. It's got an, okay. It's square waving around a, yeah, okay, this could be why. So let's go for, I assumed that it was going to be taking it off 0, but it's not. It's taking it off 3.3. Let's try that. Not 3 millivolts, I want 3 volts. Why are you giving me millivolts? So just to explain what's happening, what I think is happening is the oscilloscope is showing that we are getting a square wave that is peaking at only about 2 volts because it is centered around 0, and this is giving me a positive and negative. It's actually going to minus 2 volts almost on the output. And so I need to apply the offset to move it all up so it's all positive. And that's probably why it is not triggering the input on the thing. What am I doing? Offset, offset, offset. Low, offset. Oh yeah, look at this. You can see high 1.6, low 1.6. All right, offset. I want to set that offset, but I don't want to set it to millivolts. I want to set it to volts without having to do that for an hour. Oh, okay, I can go left up to volts. All right, so that is counterintuitive. Offset. I'm going to give it a 2 volt offset. That's close enough. And now I can see on my oscilloscope that it is sitting approximately around 0. So that looks about right. All right. But I am not seeing anything on... Okay, back to the computer. And now let's see what's going on. I'm not seeing any inputs changing on this. So, what am I doing wrong? I've got to stop and think about this for a second. Okay, we've got it set to 100 Hertz. Let's go for a much lower frequency, just to... Let's make it like, we'll make it 1 Hertz. And now, okay, now I can see, oh, this is interesting. Okay, I'm going to throw you back to the view. So, to summarize where we are right now, we are generating a 1 Hertz square wave, 3.3 volts, peak to peak, basing it up off 0, going into bit 7 on this. I mean, this is all a bit offset and you can't quite see what's going on. Being read by this, and now this is what is coming up in the serial console. What we should be seeing here, I'm going to change this delay to 100, just so that we're getting 10 readings per second, which means we should be getting 10 readings of one value and then 10 readings of another value, and it should just be alternating between them. Upload. Now what will be interesting also is changing this to another input that does not exhibit the problem, just to verify that this is not being crazy because of, oh come on, you can do it. Just to verify that it's not being crazy because of my test setup being screwed up in some way. So in a moment I will unsolder that wire and I'll connect it to a different input, and we'll see, like a different bit, and we'll see what happens. Connecting, why can't you connect anymore? What's wrong with you? Let's just try again. I've just hit reset. I need someone here to keep feeding me iced coffee or something. An error occurred. All right, I'm going to turn off that input. In fact, I'm going to disconnect. What am I going to do? Because sometimes I've noticed that with uploading, you can have trouble. This might just be my imagination. I don't know if this is a real thing or not. But I've noticed that if I have a device that is busy processing things, sometimes it has trouble going into programming mode. Now I'm going to pull that entirely. Which really should not be the case, because hitting reset on it should make it impervious to whatever else it's doing. Come on. Yes, uploading. Okay, this is better. Sion said close the serial output. Yeah, I already have. That was closed already. So, okay, this is what we're getting. And if I turn on the signal generator, look at that. we're definitely seeing the problem. There's something weird going on with with one of the other bits. So with bit 1, when bit 7 is being asserted, bit 1 is also being asserted. That is really interesting. Okay, now, and the thing is that it seems to be doing it consistently. Like, the consistency of that makes me think that I've got a problem with my test setup. So I'm just going to turn off the signal generator, and we're going to get all high values again. And what I'm going to do now is change this lead, which is going to bit 7, to one of the other bits, just to see if we get a nice clean transition. So I'm going to turn, what I'm going to do, I'll turn everything off. Turn off the signal generator, turn that off, disconnect the oscilloscope, and unplug that. Okay, so now I am going to, what do I want to do? I want to go for which bit? Or so at the moment I've got it connected to bit 7. Let's go for bit 6. Okay, so it's front edge and it is 1 pin in. All right, front edge, 1 pin in, which is that one there. So solder it onto that. Back over again and plug USB back in, turn on the signal gen. Now over here we've got, all right, here we go. So now we have all 8 bits high. I'm going to turn the signal gen on and we'll see what happens. Look at that. That is nice. That's exactly what we would want to see. So I think we really have found the problem. Like, we've actually seen it doing it for real. But what worries me is how consistently it is causing problems on bit 1. It's not just like some random times. It's like every time bit 7 is asserted, bit 1 is also asserted. So yeah, what we're seeing there is reading bit 6, and it is changing, but nothing else is changing when bit 6 changes. So we're getting a nice clean input. And now, just to verify this, I probably should have stuck a different, a separate wire onto it, but oh well, this is the way it is. So I'm going to unplug that, unplug this again. I'm going to put it back because I want to see that problem reoccur. There, and put it back onto this pin here. And reconnect it. Reconnect serial. Back to here. Well, the problem has gone away. Oh, hang on, no, something strange happened there. Oop. Look at this. Oh no, it didn't. It was just because it changed the it changed the number of digits in the timestamp. The problem has stopped. We're not seeing it. I'm pretty sure that we were seeing it before, unless I was going crazy. I hope everybody else could see what was happening. But now this is behaving properly. So maybe my test setup was a bit dodgy. Maybe it was some crappy connection on something. Let's try, what'll I try? Okay, what I'm going to try is increasing the frequency on the square wave. Sion says bad solder joint before. Maybe. That doesn't explain why it was appearing on bit 1 though. So, let's try... So it's currently set to 1 Hertz. Let's go for... what do I do? Let's go for 100 Hertz. Why did you do that? 100. What's it? Microhertz. Why does it default to the smallest possible unit? Ah. Can I go left and add a number out here somewhere? Like if I put a 1 there, 1 Hertz. Okay, let's just try this. I'm going to go select 100 Hertz. Oh, okay. It's just me being stupid with the user interface. Okay. Now, turn the output off, turn it back on again. This is another interesting thing. Okay, so what you can see is, if I switch you back to here, okay, what you're seeing here is 7 bits because the most significant bit is being asserted and it's being truncated. But if I turn off the signal generator, look at that. So that is 8 bits. And so, oh, hang on, I've got to mute again. Okay, that is 8 bits. So now if I turn the signal generator back on, you can see that it is just constantly asserting that bit. And I wonder why that is, because what we should be getting, I'm now feeding in 100 Hertz, which is not an excessively high frequency. We are reporting at 10 Hertz. So we're doing in tenths of a second there. So what we should be seeing is randomization almost in the length of this. And we're not. It's like it's just permanently asserted even though it's coming in as a square wave. Hopefully. Assuming that, oh yeah, the offset is still the same. Yeah. Just to verify, I'm going to reconnect my oscilloscope, which sadly you can't see. And yeah, I've got a square wave. It's saying, well, it's hitting 4 volts max, which is okay. Then it's got amplitude, yeah, okay. That all seems fine. Let's try, I'm just going to decrease this to, just going to make it 3. No, that's not what I wanted. No. 3 volts. That's better. Okay. 3 volts peak to peak. That'll do. So now I'm seeing a 3.8 volt max because we've got that slight offset. It's offset off the 0 a little bit. Martin says, capacitive hysteresis on input. Do you have pull down resistor? No, I've got pull up resistors. So I've got 10k pull ups. Yes. Paolo said, static unsigned long time debug equals millis. I don't understand how that would help. Anyway, output is turned off, and now we're not seeing it asserting that at all. Oh, and now it is. When I'm turning the output on and off, sometimes it's asserting it, sometimes it's not. See, that's with the signal gen off. That's now on, and it's not asserting it. Turn it off, turn it on, and it is asserting it. But it's not changing. So there seems to, maybe it's just a frequency limitation on the MCP, although 100 Hertz seems to be yeah, sample rate aliasing. Yeah, says Martin. Martin said sample rate aliasing. I'm pretty sure you've got the problem there. All right, let's change that. So the explanation of that is it's a matter of the timing. If you are sampling at a rate, hang on, no, but our input is at a higher frequency. Yeah, so what happens is that the timing just happens to align that every time we are sampling, it is at a point where the input is either high or low, and they're staying in sync. And eventually over time they might drift out of sync, but they're staying in sync. So if I change this delay, instead of being 100 milliseconds, say I make it 89 milliseconds, and then we'll upload this. What should happen then is that the timing of the sample and the signal will no longer be staying in lockstep. It'll be sort of one will be shifting sideways relative to the other. So now we should see some more interesting things. Yeah, Scott says get rid of that delay and just output it as fast as we possibly can. I'll turn the input on. Yeah, so now we're seeing it change. Yes, so Martin, you are absolutely correct. It was aliasing on the sample. But what we're not seeing is the false triggering input anymore. But yes, I will get rid of the delay entirely. Let's just read this and spit the values out as fast as possible. The reason that I didn't want to do this is that I wanted to have enough visible on the screen to have some context. Dentistry says, could it just be randomly based on something when the chip starts up? So when it is turned on and off, the problem vanishes but could reappear when power cycled. Maybe. And yes, Peter, I am past lunchtime now. All right, so signal gen on. So now we can see it's just zippity doing up the screen, like too fast to really be able to see context. But what I'm not seeing is that problem that we had before where we were getting a 0 in bit 1. Zoomies, yeah. I have not seen that happen. So I've in the forum post, in the microchip forum, people were complaining about this when they were doing 1 megahertz inputs. So let's leave the input just sampling and reporting as fast as possible and increase the frequency on here. So let's go up to here and do 1 megahertz. Now that I've got some clue of how this user interface is working, it makes so much more sense. And let it do its thing. Okay. What is going on here? Yeah, look at this. It's having trouble with the sample, like 93606. The higher, somehow, the higher frequency on the input is causing the Arduino, or the ESP32, to have trouble reporting the read, which should be entirely independent. That is very odd. I'm going to hit reset on the REC32. Yeah. See how long it's taking to get to each one? It's taking about a second. In fact, why is that exactly on a second almost? There is no delay in here anymore. But it's basically taking 1 second. Oh, it's triggering interrupts. Jordan said. But is it? Because we've got I squared C. I'm not actually reading any interrupts off the MCP at the moment. The interrupt pin is not even connected. So I don't think that's it. But Yeah, this is only reporting once per second. Wonder what happens if I do put a delay back in here. Does it then start doing its thing a bit better? Yeah. And that's a very good question. Chip said, why would it be so regular? That's right, it's like precisely on 1 second increments, which is very, very odd. So now I've put a delay back into it for 89 milliseconds, which means we should be getting about 11 values per second. And we're still not. It's kind of randomizing it. I think it's ending up being the 1 second plus the 89 milliseconds, give or take. But it's not dealing with that high frequency input at all. So what I'm going to do is leave this visible on the screen so that you can see it, and I'm going to decrease the frequency on the signal generator. So at the moment it's set to 1 megahertz. I'm going to set it to 500 kilohertz. So it's now 500 kilohertz, and it's still stuttering. I'm going to set it to 100 kilohertz. Yeah, we've now got a 100 kilohertz input on the signal generator, and the serial on the ESP is now keeping up with it much better. So it's having trouble with the reads of the it's having trouble with the reads on I2C when the input is changing quickly. I'm getting rid of that delay again. Yeah, Michael said serial buffer, but I don't think so. I think this is more related to the I2C communication with the MCP and trying to read from it when its input is fluctuating rapidly. Alright, so now we're getting, it's still stuttering, but we're getting the different values. So this is with the MCP being exercised at 100 kilohertz. I'm going to change it to 1 kilohertz. So we'll do 1 kilohertz, boom. Okay, and now it's stuttering occasionally, but it's doing a much better job of keeping up with its input changes. Jordan asked, what's your I2C data rate? And Austin said it's either 100 kilohertz or 400 kilohertz. Yeah. Peter said, chicken sandwich. Oh, I'm hungry. Yes, it's lunchtime. So Martin says, what's the spec sheet for MCP say for input hertz? That is an excellent, excellent question. At what point is the MCP going to become unhappy? MCP 23017 datasheet. I am just going to pull it up and let's see if we can find something useful. Datasheet. Add some readability. So, no, that's not it. Hang on. I clicked on download datasheet here, and I got this. What's going on? Microchip. Oh, hang on. How did I end up there? Oh, that's auto. What? It's an autocomplete thing. That's my problem. Okay. So, high square. Blah blah blah. Let's see. What does it say about input frequency, if anything? It might just have like rise and fall times or something on the inputs. Electrical parameters, low voltage, high capacitive loading, device timing specifications. Okay, now that's on communication, which we don't care about. Has anybody else found this? Is it possible that control registers are not being set properly on power up design flaw? I don't know. Data timing. Oh, my stomach is really telling me that it is lunchtime. So far today, I only had breakfast. I didn't have second breakfast because I was busy helping Lachlan move around some of the pallet racking. And my stomach is reminding me that it needed second breakfast. What am I looking for? That's right. No, I don't care about the I2C side of things. I don't care about the SPI side of things. What I'm looking for is timing. I should have looked at the index, shouldn't I? I'm just scrolling through the datasheet kind of randomly. That's not the efficient way to be doing this. Let's go back up near the top. Where's the index? Come on, microchip, give us an index. Where? There is no index. What? Why is there no index on this datasheet? All right, let's just look for frequency. Frequency, clock frequency. No, that's on serial bus frequency, etc. No, that's not it. Power on reset. Serial bus frequency, that's not what we want. What about rise time? Rise rate. But that's probably how it'll be defined in there here. Clock rise time, VDD rise time, and varisense. No, it doesn't say anything about that. So I can't see anything in particular about maybe sample rate. No. Let's just search for rate. Operate. No. Rise rate to ensure power on reset. Operate. Lots of operates. Generated. The slew rate function on this. No, that's I thought we were onto something there for a second. Bank. No. Slew rate control. I suspect generates an interrupt. It's not going to tell us. Yeah, we're into the trademark section. I don't think the datasheet actually gives us anything in terms of what it can deal with for an input frequency, which is kind of annoying. Oh, page 6, John says. Mouser datasheet, page 6. Okay, where? Page 6. Yeah, that's all I2C frequency stuff. That's not the input frequency. I don't care about the I2C frequency at this point. Yeah. What I want is the rise and fall time on the inputs. On front page, configurable interrupt source. Interrupt on change from configured register defaults or on pin changes. Yes, I'm not using the interrupts though, so it doesn't matter. There's, if we go back to Eagle, and where are we? Let's have a look at the schematic. The schematic, oh, pull it up here. Let's just go to one of them. So we've got interrupt A, which is here. So it's the interrupt coming off port A. There is a net connected to it. Does it go anywhere? Show. Yeah, I'm pretty sure I just brought it to a header on here. Int A. Where is int A? Int A. Where did it go? Let's go show int. There it is. Yeah, so there's the trace. That's the interrupt coming off the chip, and they are all joined together because you can do that. And then it comes across here and it just comes to this. It's not actually connected to anything right now. You can put a jumper on it, you can read it if you want to, but right now we're not using it in any way. So if the chip is generating the interrupt signal, it's not going anywhere. And these are all like high impedance, active low outputs, which means that what you can do is tie the interrupt outputs from multiple chips together, and then you can read it and detect it, and then you've got to scan the chips to find which one actually generated the interrupt. But that should not be stopping us from working right now. Yeah, so Stephen said Johnny's going to starve himself for our benefit. Oh, Scott said table 1.5 GP and int pins requirements. Let's see what that has to say for itself. Table 1.5. Where is table 1.5? That's table 2. Why is it starting with table 2-1? What happened to 1? Table, come on. Table, 450 nanoseconds. Ooh. Yeah, Chip asked, is it a problem if the input is changing while the chip sees it? Will it produce uncertain results at times this is happening? The short answer is it should be okay, because the chip, the MCP should sample its input and then depending on the thresholds, it should take a definitive value. Page 10. Okay, thank you, Scott. Page 10. It is saying GP input change to register valid. General purpose input change to register valid 450 nanoseconds. Aha! Cool. Now, someone quickly convert that into a frequency. Okay, what... I'm going to ask Google, what frequency has 450 nanosecond interval? How do I calculate a time frequency if I know? Divide... come on, just tell me the answer. Divide 1 by the frequency. I would have thought there would be a simple online calculator for this. You know, like you can... I know it's a simple calculation, but I can't be bothered doing it. Period of Omni calculator. Okay, here is, so frequency period. Nanoseconds, 450 is 2 megahertz, 2.2 megahertz. Okay, so it should be able to handle an input of up to, well, if that's the frequency, it needs 450 nanoseconds to be stable. So the period of 450 nanoseconds, we've got to divide it by 2. Yeah, 50% duty cycle, that's right, 1 megahertz. Yes. So as Martin says, it's 2.1 megahertz, but if we're running a 50% duty cycle, the 450 nanoseconds is the period during which it has to be at a stable state, which means it's double that so it's 900 nanoseconds, which makes it just over 1 megahertz. Okay. Note 1 is interesting. Where is note 1? This parameter is characterized, not 100% tested. Oh, that's glitch filter on general purpose pins, 150 nanoseconds. Yeah, okay. Now, what we're talking about here is really the extremes of performance when we're pushing it out to the limit. So I now have it running at 1 kilohertz. So we're feeding it 1 kilohertz in, and it seems to be behaving normally. But okay, apart from that thing that we saw early on, I suspect that we have failed to demonstrate the problem, which is disappointing. I wanted to see this problem. Now, we did see that really strange result when I first connected it, but now I am not certain that what we were seeing was real. It could have been something else going on. Something like a bit of solder on the workbench doesn't really explain it though, because it was changing in bit 1 was changing synchronized with bit 7. Whenever bit 7 was low, bit 1 would also be low. But now we're not seeing that, so I don't know. Yeah, Scott says, first results were due to conductive dust in the air. Oh, Henrik. Henrik and Peter and my stomach are conspiring to end the stream. So Henrik said, John, would you like to see pics of freshly cooked sweet and sour chili chicken? Oh. And Peter says, hey, you want a pizza? Oh, I sure do. Jordan says, where is bit 1 on the connector? That is a really good point. Let's check, because if bit 1 and bit 7 are adjacent and I had screwed up somehow, that could have been influencing it. So let's come back to here, and see bit 1 and bit 7 on the connector. So we have bit 7 comes down to here and it goes to that pin there. So we've got to remember that's the pin we want. And then bit 1 is that one, which goes to that one there. No, they're actually on different parts. Well, they're in general proximity, but not close enough that it's likely to have been shorting. So not between those pins on the connector anyway. So I think it's time for me to go and get some pizza. I am really hungry. There is a luckily there is a reasonably decent pizza shop fairly close to here. Okay. Jordan says their traces overlap. They do. So what are we on? Which layers? We've got yeah, opposite sides of the board. They overlap briefly as they pass between here, but that's it. That shouldn't be enough for, and they're input pull-ups, so that shouldn't be enough to induce a spurious signal on the other trace. So yeah, Stephen said inductive coupling as well. Sharky said turn the board over and check that you connected the wire back correctly. Doing this carefully so I don't move wires where they should be. Yeah, the connection looks good to me. Yes. Given the state of my stomach, I think I'm going to call it. And because my brain is fading, because my stomach is running out of fuel to feed it with. It needs to take in some food, convert it to glucose, shove it into my bloodstream, and circulate it to my brain. Oh, right. So, I'm kind of disappointed that we are... I pressed the wrong thing. That's what I wanted. That we are not seeing the fault occur here. Not the way it's been described anyway. I am not convinced. I am kind of tempted to power cycle it. I just turned off the signal gen. I'm tempted to power cycle it to see if it can come back. So I'm going to disconnect USB. So USB is gone. It's powered down. Plug USB back in again. And now it's back, it's doing its thing. I'm just going to disconnect the USB and plug it back in a couple of times. I really don't think this will be it. Oh, and Scott pointed out it has been described as a random fault. Yeah, but I've also seen it described as something that can be reasonably easily reproduced if you feed a square wave into it. Keith said, are bit 7 and 0 next to each other on the board, i.e. solder short? No, that was what I just checked a moment ago. So that was this. We've got where we were seeing it was, this is bit 7, this is bit 1, and we were seeing the effect introduced, like when we asserted bit 7, we were seeing the output on bit 1 also change state. And the traces here are on opposite sides of the board, so it looks like they intersect, but they don't. And they should be fairly well isolated from each other. And this gap here is between the 2 rows of the connector, and that is a reasonably significant gap, so there's no like solder whisker or anything between those. Not that I can see anyway. Alright. Tony Smith said, report I have read, have to feed 1 megahertz for a few minutes before scene, then it's random. Yes. Okay. I'm going to... Yeah, well, this has been running for a while. What is it, 90 seconds since I reset it. This is only running at 1 kilohertz. So, yeah, I can switch it back to... I'm going to switch it back to 1 megahertz. So I'm going to go 1 megahertz. So now we are getting 1 megahertz into it, and we're getting that weird thing before where it is screwing up on its reads. Michael said, don't put squirrels in front of John when he's already over time. Yes, I will chase that squirrel. But if I don't want to stop without having seen this. I want to actually cause this problem to be visible. Stephen asked, how do you reliably monitor 1 megahertz with a 400 kilohertz I2C bus? The result is that no, you can't. So what will be happening is that the square wave at 1 megahertz is coming into the input on the chip, and we are reading it at a dramatically lower frequency than that. So we're going to be missing most of the pulses that are coming in, but that doesn't matter. We're basically just reading it as fast as we can, and that should be enough that we see at different points of the waveform, we should see different values, like we should see that input changing state. Yeah, Henrik said, you can't make it visible, there is no fuel left. You're right. I have no fuel left. I have run out of fuel. But it's now been running for a little bit, and dog versus squirrel equals time. Yes, chasing the squirrel. Okay. Well, we had a go. Imogen said, have a good lunch using the air fryer today. No, not now. I am probably just going to go and get a pizza now, I think is the thing to do. And I will use the air fryer for reheating pizza later, but for now I'm just going to get it fresh from the place down the road. I used the air fryer to make dinner last night. I had chops and chips, or what in most parts of the world they would call fries. Got a potato and just sliced it up thinly and put it in the air fryer and made fries. Air fried the fries, and it worked out really well. Oh really? Is that Austin? Austin said, Cable Tie offered you to come get pizza from his oven. I must have missed that. Oh, Cable Tie. That is very, very generous. I would love to come there for some lunch. Yes, please. I'll get off the stream and I'll contact you directly and we can make the arrangements. So that would be really, really cool. But getting back to what's going on here, we're not seeing it. We're just not seeing the glitch, which is very, very sad. Yes. Oh well, being unable to reproduce it at this point, I'm going to wrap it up. And I'm going to go and see Cable Tie for some lunch, for some pizza. Oh, that is such a good offer. Okay. Oh, Michael says, come to Geelong and we can go around the corner and shake Kathy's door. Yep. Have pizza with Kathy and Michael. That'd be cool. And pizza in Ballarat with Chip. That would be cool. Yes. And Imogen. Yeah. Okay. My brain is so fried now. Right now, I'm not even sure how to end the stream. I suppose I just have to say goodbye, don't I? Okay, well, we had a good go at seeing this problem. I'm disappointed that I didn't. I might leave it running and just see if it shows up after a while. It may not. Yeah. Okay. I'm going to go. I hope you are having a great weekend and you continue to have a great weekend. And I will see you all really soon. So thank you very much. Go and build something awesome.